Okay, if you just get Griffin, if you go to course Blackboard, and I just made this one video recordings from class demo slash lecture. This one basically have I am recording my screen. I'm doing screen capture right now.
At Friday 10:30
this will
to
be posted
1:10
on this playlist. So
at here.
you missed
Art and
last
Design Building
week, and then
2001.
last week
My name
I
is
already
Sang Nam,
went over how to do
if you know
how to
more
use
about
Euphoria
me,
plugin,
you can go to
and so try to catch up. Okay, and then there will be
system as a plugin.
assignment
Okay.
due soon.
So you don't have
So
to
try to
download
watch the
anything.
video and catch up what you missed last week.
Image.
Okay. Okay, week number 2. Actually, before we start, everyone did their introduction. Then actually, you can watch the video from people's instruction. And I want you to introduce yourself to the class briefly.
How what do I say?
Yep.
I'm Griffin Latessa, junior year student here at George Mason. I major is computer game design. Happy to be here.
Okay. What's your strengths? What's your specialty?
Like in game design?
Yeah.
I guess I'd say animation.
Animation.
Yeah, 3D modeling and such, but I'm still learning.
Great. Because we had like 6 students in this class, so we're gonna have like a group project literally for every project.
Okay.
And everyone will take a part in graphic art or programming or some sort of different types of computer game design aspects. And it's great that you have expertise in graphic art. Great.
Thank you.
All right. Wing number 2. Let's try to get to know what this AR is a little more. So you can go to this lecture on AR and you can download this PowerPoint file. And let's talk about what this is. So augmented reality. So how I lay out this course is, I would say we can divide this course by 3 parts. And one, we're going to do AR, augmented reality. And then second portion, we will use more like a smartphone virtual reality, smartphone VR. And then third part will be virtual reality using HTC Vive. And in that process, I'm going to throw in some other things as well, such as virtual reality using Oculus Rift or Oculus Go and some other things. But mainly, this course is about production. I try not to spend much time on theory. I want you to actually spend more time on making something. Okay, so that's why we have this small assignment due next week, and then we are going to start a little larger scale augmented reality as a group together soon. Okay, what is AR? AR, augmented reality. I mean, we had this discussion a little bit. Tony, what is AR? No. What is it? And another thing is, again, like that we will work in team environment. Soft skill such as communication or presentation skill is really important. Okay, so make sure, I mean, you practice speak to other people, others in team members, or even in this class or in different settings. It's really important for you to be able to speak up and speak to other people to speak to other people about your opinion. That's why time to time, yes, I already have good definition, but I want to ask you, and I want to actually hear from you. Griffin, what is AR?
Taking virtual imagery and overlaying it over real life.
Okay, that's good definition. Okay, that's good definition. Anyone else? Again, it's important for you to be able to say what you can do. So after this class is over, hopefully you will be able to say, oh yes, I know how to create AR and BR, and then AR is this and that. Okay, you should be able to speak about what you can do. So I have few definitions. Okay, augmented reality is a live, direct, or indirect view of a physical, real-world environment whose elements are augmented by computer-generated perceptual information, ideally across multiple sensory modalities, including visual, auditory, haptic, somasensory, and olfactory. So here, I really want you to think about the application of AR when you think about the definition of AR. So like last week, I mentioned that to me, this is all about information. So without AR, you will get one single layer of or single dimension of information. With AR, you will be able to add more information. So usually that information is computer generated. It could be text, music, so audio, or video. Okay? Sometimes it's animated. But bottom line is AR allow us to display or add one more layer of information on the top of existing physical information. Okay? So if you look through some other definitions, they're basically talking about the same thing. You have this physical environment, and on the top of it, you basically add more layers of information. And then usually, because of current technology, people now try to use 3D models or 3D animation. So a lot of times they're thinking AR is generating 3D models on the screen. Okay, so that you can mix the reality with this computer-generated animation. But at the same time, it could be text or audio or all different types of information. So here, overlay sensory information can be constructive, for example, additive to the natural environment, or destructive, masking of the natural environment, and is special registered with the physical world such that is perceived as an immersive aspect of the real environment. In this way, augmented reality alters one's current perception of a real-world environment, whereas virtual reality replaces the real-world environment with the simulated one. Augmented reality is related to two largely synonymous terms, mixed reality and computer-mediated reality. So these are kind of good information to know. But again, these are not something you have to memorize. But I want you to develop your own definition so that later you can explain what AR is to other people. And then hopefully you'll be able to develop a simple AR application. And when you have to explain what you did in that project, I hope that you can explain all these aspects of augmented reality. And what is AR continued? A combination of a real scene viewed by a user and a virtual scene generated by a computer that augments the scene with additional information. So again, AR will be utilized more and more because this ability to add more information. If you just share some information in the physical world, there's definitely limitation. You can only share what people can see or feel or hear. But using AR, augmented reality, you can actually add more information on the top of existing the physically constructed world. So in a sense, again, to me, it's all about information. And with your eyes or hand or ear, again, the amount of information you can get is limited on that spot. But using AR, you can actually add more information to share. So this is like one example from
We're going to be
Iron Man
moving
2.
away from containment and onto information everywhere.
Magic Leap's technology is reportedly built around something called a dynamic digitalized light field signal.
Yeah, it's like I'm right there. Like you're in the bathroom. This is cool.
Oh, there you go.
It's just not possible to. Now, what you've just seen is a vision of how HoloLens could enhance one single subject.
This platform is going to truly blend your digital life with your physical life. And it is so thrilling. This is truly about seeing the world in a whole different way.
So these are one example, and then this actually.
If you're looking for a travel agency to help you with your next vacation, look no further. Not only will we get you the best deals possible, but we'll take care of planning each portion of your trip, from airport transportation, airline tickets, car rental, and hotel lodging. We can do it all, and in most cases, we can get you better.
So now you can think about like how you can actually create something like that. One thing you can see is this one would be this business card is a visual marker or image target, and then it plays basically pre-recorded video.
Look no further. And then those discs, simply contact one of our for you.
And then anything else, pretty much the same thing. Alright, so this is a simple example of augmented reality, and hopefully with what we did last week, you'll be able to create something similar to this. So again, an AR system as virtual computer-generated object, audio, and other sense enhancement to a real-world environment in real time. Okay. And now let's try to think about this. So what's the goal? What's the goal of AR? So everyone uses AR, and then what would be the goal of AR? Why do we have to use AR? Why? Anybody? So let's say, yes, we want to create this AR application, and why? I mean, and then what can AR do? What's the goal?
Better access to information. No.
Yeah, I mean, obviously, I mean, like, if you focus on information, obviously, if you think about that business card, the amount of information you can share using the business card is limited. But if you use AR, you can add a layer of information such as video or animation or something more. Same thing for that AR book types of thing. Like if you remember the example of that the heart, if you look at the 2D image of heart, obviously there's a limitation. But if you use AR, you can actually show that heart in 3D shape with animation, possibly some sound, so you can actually give more information. So obviously we want to augment reality we are in using this augmented reality. So few things you can think about is to enhance a person's performance and perception of the world, and ultimately to create a system such that a user cannot tell the difference between the real world and the virtual augmentation of it. So we want to add more information, and we want to obviously put more realistic or convincible the computer-generated information, so that we can completely mix these two together to give more information. So whenever we talk about AR, we usually talk about virtual reality at the same time. So those two terms, if you think about augmented reality and virtual reality, I mean, both terms are about reality. Either you can augment the reality, or you can create a virtual reality. So they usually come together. It's important for us to know the difference between AR and VR. So augmented reality is system augments the real world scene, and user maintains the scene of presence in real world, and needs a mechanism to combine virtual and real world. So you still see certain things in physical world real time, and then computer-generated information will be added to the real world you see. So as a user, okay, you still see something in physical world, and you basically combine these two together. Whereas virtual reality, okay, totally immersive environment, means you actually get alienated from the reality, and you actually put yourself inside of this virtual reality. And virtual scenes are under control of system. In other words, if you use AR as a user, you still see the physical world, okay, and then you still have control of the change the scene, meaning you can move around, or you can have control over what to see and what not to see. But in virtual world, your scenes, whatever scenes you see, actually controlled by the system, and the experience will be totally immersive, meaning alienated from the real world. So in terms of that difference between AR and VR, there's Milgram's reality virtuality continuum. Okay, this is if you study AR and VR, this is things we talk about time to time. So on your left side, this is more about real environment. On your right side, there's the virtual environment. So if you think about AR and VR or AR AV, so usually we talk about this 4 different stages. So real environment to the left, okay, and then augmented reality, meaning you mix some computer-generated information with the real environment. Okay? And then there's augmented virtuality, meaning you actually have this the mixed AR and VR. So you kind of see like 3D avatars in real world, or you see real people or image of real people in virtual world. So the mixture of real world and augmented reality. And then there's virtual environment. In the same way, this is more examples of reality virtuality continuum. So this one would be reality. Okay. And augmented reality, so this is like chess player with a robotic arm or robot that plays chess. So reality is this. And then this can be, you can use or implement augmented reality for this robotic arm. Okay. And then you will have the real chess player play the chess against this augmented or computer-generated image of robotic arm. And augmented virtuality is the video with digital video or some augmented information. So this one, in this particular example, they basically have this 3D images or 3D models of chess player playing chess. And this image can be portrayed or projected in real world. Okay. And then virtual environment, everything's in 3D or computer generated images. So another thing would be mixed, in terms of mixed reality. Okay, real world would be real 3D models of something. Augmented reality is you can project something on that someone's face. Augmented virtuality is, again, mixture between AR and VR. And virtual environment would be everything's generated by computer. Okay. And how AR works. This is important. So we talked about how to use Vuforia. So in my demo, I try to explain like few steps, such as we create this image target, and this image target would be recognized by system and trigger this appearance of your 3D model or image. That's what we did. And let's try to look at how we can deconstruct this technology. So there's one interesting TED talk. So let's kind of watch this together, and then we will review key technologies in AR.
So wouldn't it be amazing if our phones could see the world in the same way that we do? As we're walking around, being able to point the phone at anything, and then have it actually recognize images and objects like the human brain, and then be able to pull in information from an almost infinite library of knowledge and experience and ideas. Well, traditionally that was seen as science fiction, but now we've moved to a world where actually this has become possible. So the best way of explaining it is to just show it. What you can see over here is Tamara, who's holding my phone that's now plugged in. So let me start with this. What we have here is a painting of the great poet Robbie Burns, and it's just a normal image. But if we now switch inputs over to the phone, running our technology, you can see effectively what Tamara's seeing on the screen. And when she points at this image, something magical happens.
Now summer blinks on flowery.
Now, what's great about this is there's no trickery here. There's nothing done to this image. And what's great about this is the technology is actually allowing the phone to start to see and understand, much like how the human brain does. Not only that, but as I move the object around, it's going to track it and overlay that content seamlessly. Again, the thing that's incredible about this is how advanced these devices have become. All the processing to do that was actually done on the device itself. Now, this has applications everywhere, whether in things like art and museums, like you just saw, or in the world of, say, advertising or print journalism. So a newspaper becomes out of date as soon as it's printed. Here is this morning's newspaper, and we have some Wimbledon news, which is great. Now what we can do is point at the front of the newspaper and immediately get the bulletin.
You adapt, and you have to be flexible. You have to be willing to change direction at a split second. And she does all that. She's won this title.
And that linking of the digital content to something that's physical is what we call an aura, and I'll be using that term a little bit as we go through the talk. So what's great about this is it isn't just a faster and more convenient way to get information in the real world, but there are times when actually using this medium allows you to be able to display information in a way that was never before possible. So what I have here is a wireless router. My American colleagues have told me I've got to call it a router so that everyone here understands. But nonetheless, here is the device. So now what I can do is, rather than getting the instructions for the device online, I can simply point at it, the device is recognized, and then...
Begin by plugging in the grey ADSL cable, then connect the power, finally the yellow Ethernet cable. Congratulations, you have now completed setup.
Awesome, thank you. The incredible work that made that possible was done here in the UK by scientists at Cambridge, and they work in our offices, and I've got a lovely picture of them here. They couldn't all be on stage, but we're going to bring their aura to the stage, so here they are. They're not very animated. This was the 4th take, I'm told. Okay. So, as we're talking about Cambridge, let's now move on to technical advancements, because since we started putting this technology on mobile phones less than 12 months ago, the speed and the processor in these devices has grown at a really phenomenal rate. And that means that I can now take cinema-quality 3D models and place them in the world around me. So, I have one over here. Tamara, would you like to jump in? Actually, So then, after the fun, comes the more emotional side of what we do, because effectively this technology allows you to see the world through someone's eyes, and for that person to be able to take a moment in time and effectively store it and tag it to something physical that exists in the real world. What's great about this is the tools to do this are free, they're open, they're available to everyone within our application, and educators have really got on board with the classrooms. So we have teachers who've tagged up textbooks, teachers who've tagged up school classrooms, and a great example of this is a school in the UK. I have a picture here from a video, and we're now going to play it.
See what happens. Keep going. Now move it either side, see what happens. Move away from it and come back to it.
Oh, that is so cool! Just a normal piece of paper.
And then, have you got it again?
Oh my god! How did you do that? Because it's in my iPad. That's
So it's not magic. It's available for everyone to do, and actually I'm going to show you how easy it is to do by doing one right now. So I'm told it's called a stadium wave, so we're going to start from this side of the room on the count of 3 and go over to here. Tamara, are you recording? Okay, so are you all ready? 1, 2, 3, go! Fellows are really good, huh? Okay, now we're going to switch back into the Erasmus application. And what Tamara's going to do is tag that video that we just took onto my badge so that I can remember it forever. Now, we have lots of people who are doing this already, and we've talked a little bit about the educational side. On the emotional side, we have people who've done things like sent postcards and Christmas cards back to their family with little messages on. We have people who have, for example, taken the inside of the engine bay of an old car and tagged up different components within an engine so that if you're stuck and you want to find out more, you can point and discover the information. We're all very, very familiar with the internet. In the last 20 years, it's really changed the way that we live and work and the way that we see the world. And what's great is we sort of think this is the next paradigm shift, because now we can literally take the content that we share, we discover, and that we enjoy, and make it a part of the world around us. It's completely free to download this application. If you have a good Wi-Fi connection or 3G, this process is very, very quick. Oh, there we are. We can save it now. It's just going to do a tiny bit of processing to convert that image that we just took into a sort of digital fingerprint. And the great thing is, if you're a professional user, so a newspaper, the tools are pretty much identical to what we've just used to create this demonstration. The only difference is that you've got the ability to add in links and slightly more content. Are you now ready?
We're ready to go.
Okay, so I'm told we're ready, which means we can now point at the image, and there you all are. 1, 2, 3, go! Well done. We've been Erasmus. Thank you.
All right. So you can watch this again later if you want. But bottom line is, I want you to think about the technology used here. So if you can actually define some common groundwork here is, he shows some image. And then that image, whenever he actually used that particular image, you could see this loading sign, meaning there's a visual or image recognition system. So it recognizes that image. If that image is matched with some visual marker or image target in the database, it actually triggers something. Okay. So key technology would be image recognition. And image recognition triggers augmented reality and embeds computer-generated information to enhance the reality. So if you think about the steps of how we can reconstruct this AR project, okay, you have to have, in a real-world scene, okay, there's image recognition. So usually image recognition of 2D image, or sometimes it can be 3D object, okay? And then it will trigger to add virtual object on the top of existing physical world using the screen, usually screen on your smartphone, okay? Or sometimes delete real world object. It's not really deleted, but sometimes people actually put this computer-generated information on the top of existing information. Okay? So that is a subtractive augmented reality, meaning it will place some sort of video over the existing image target. So on the screen, you actually don't see that image target anymore, but watch video or some other information. And not virtual reality, since environment is real and no 100% immersion. So Snapchat is another example of augmented reality. They actually use facial recognition system. So they recognize face, and then they display some 3D images or some 2D animation. So this one explains actually about facial recognition system.
Hey Joss, I have a question for you. Do you know how these Snapchat filters work? Like behind the scenes?
I have no idea.
Well, do you think you could find out?
You got it.
These are what Snapchat calls their lenses, but everyone else calls filters. They are very silly, but the engineering behind them is serious.
Oh my god.
The technology came from a Ukrainian startup called Luxury, which Snapchat acquired in September 2015 for $150 million. That's reportedly the largest tech acquisition in Ukrainian history. Their augmented reality filters tap into the large and rapidly growing field of computer vision. Those are applications that use pixel data from a camera in order to identify objects and interpret 3D space. Computer vision is how you can deposit checks with your phone. It's how Facebook knows who's in your photos, how self-driving cars can avoid running over people, and
how you can give yourself a doggy nose.
So how do Snapchat's filters work? They wouldn't let us talk to any of the Luxury engineers, but their patents are online. The first step is detection. How does the computer know which part of an image is a face? This is something that human brains are fantastic at, too good even. But this is what a photo looks like to a computer. If all you have is the data for the color value of each individual pixel, how do you find a face? Well, the key is looking for areas of contrast between light and dark parts of the image. The pioneering facial detection tool is called the Viola-Jones algorithm. It works by repeatedly scanning through the image data, calculating the difference between the grayscale pixel values underneath the white boxes and the black boxes. For instance, the bridge of the nose is usually lighter than the surrounding area on both sides. The eye sockets are darker than the forehead, and the middle of the forehead is lighter than the sides of it. These are crude tests for facial features, but if they find enough matches in one area of the image, it concludes that there's a face there. This kind of algorithm won't find your face if you're really tilted or facing sideways, but they're really accurate for frontal faces, and it's how digital cameras have been putting boxes around faces for years.
But in order to apply this virtual lipstick, the app needs to do more than just detect my face. It has to locate my facial features.
According to the patents, it does this with an active shape model, a statistical model of a face shape that's been trained by people manually marking the borders of facial features on hundreds, sometimes thousands of sample images. The algorithm takes an average face from that trained data and aligns it with the image from your phone's camera, scaling it and rotating it according to where it already knows your face is located. But it's not a perfect fit, so the model analyzes the pixel data around each of the points, looking for edges defined by brightness and darkness. From the training images, the model has a template for what the bottom of your lips should look like, for example. So it looks for that pattern in your image and adjusts the point to match it. Because some of these individual guesses might be wrong, the model can correct and smooth them by taking into account the locations of all the other points. Once it locates your facial features, those points are used as coordinates to create a mesh. That's a 3D mask that can move, rotate, and scale along with your face as the video data comes in for every frame. And once they've got that, they can do a lot with it. They can deform the mask to change your face shape, change your eye color, add accessories, and set animations to trigger when you open your mouth or move your eyebrows. And like the iOS app Face Swap Live, Snapchat can switch your face with a friend, although that involves a bunch more data. The main components of this technology are not new. What's new is the ability to run them in real time from a mobile device. That level of processing speed is a pretty recent development. So why go through all this trouble just to give people a virtual flower crown? Well, Snapchat sees a revenue opportunity here.
In a world that's flooded with advertisements, maybe the best hope that brands have to get us to look at their ads is to put them on our faces.
Facial detection has a creepy side too, particularly when it's used to identify you by name. Both the FBI and private companies like Facebook and Google are amassing huge databases of faces, and there's currently no federal law regulating it. So some privacy advocates have come up with ways to camouflage your face from facial detection algorithms. It's actually illegal in a lot of places to wear a face mask in public, so this project by artist Adam Harvey suggests some things that you can do with your hair and your makeup that can, for now, make your face invisible to computers.
So that would be a little more about AR. And again, image recognition is a key technology here because once you recognize certain image, it will give you, you can trigger certain animation or some sequenced image to complete your AR project. And in terms of AR display, there are many different types of AR display. There's head-mounted display, eyeglasses, contact lenses, virtual retina display, handheld, and spatial. So we're not going to go through everything, but these are kind of interesting aspects of AR. Like if you think about AR, right now we are using our smartphone most likely, but there are existing AR head mount sets such as Microsoft HoloLens or some other types of mixed reality headset. And display technology, there's monitor-based or head-mounted display or video see-through or optical see-through. Okay, monitor-based, okay, simplest available, little feeling of being immersed in environment. You basically take some images in real world, then you kind of mixed it in the computer and then generate it on the top of, on the surface of your screen. And whereas that optical see-through HMD, you actually have this head tracker, and then there is this usually lens or glasses. So you have this monitor, or I would say monitor or projector. Okay? So you still see the real world through the lens, and on the top of the lens, this monitor you see the reflection from the monitor, so that in this area you mix the real world and what's projected on the monitor. And then video see-through HMD, this is not necessarily recent technology, but if you actually use your smartphone can work as video see-through. So with the VR headset, now actually VR headset has this little slit. You can put your smartphone, and then you can actually use the slit as for your camera lens, so that it will actually shoot something in real time and then show that on the screen in real time. But usually there's a little latency at this point, so there's little like point some seconds delay, so people easily get disoriented with this technology. But try to think about different types of AR, and usually we would do this video see-through HMD, but we usually don't use head mount the headset because it gives us some little bit of latency. And video composition for video see-through HMD, there's chroma keying to generate or to embed what you see on this through the lens on the screen. Okay. So this is again probably we're not going to really use this, but it's good to know. Okay. And I can skim through and okay. In real-world application, medical, entertainment, military training, engineering, design, robotics and telerobotics, manufacturing, maintenance and repair, consumer design, hazard detection, and audio. There are many things you can use for this AR technology. So last time, what I showed you was one of this example. I'll just show you this one more time. So this was one of the project that I did for U.S. Army, and this is a combat medic training system using augmented reality technology. So now you can possibly think about what's happening or what's used here. Okay, so the key technologies would be image recognition. Once system recognize that particular image, it will trigger something. So we'll kind of see how it works. So this one again is a training system for combat medic. So start AR demo, and then it changes the scene to control the camera attached to the device. And then, okay, point camera at immersed target card. So I use this image target system, so which is this one. Then as you can see, okay, this image target is recognized by the system. Then it basically displays this existing or 3D animation. And then I can go next to go to the next step. So there's this animation, okay, chunk of animation. Whenever you click next, it will display the next animation. Okay. If you think about this project, I mean, this one is something you can actually create. I mean, it takes more time because of the 3D models and 3D animation. But in terms of technology, okay, it will just use image target. Once that image target is recognized, it will display that animation. Oops, all right.